Hello everyone, good morning. This is lecture number 9 of ordinary differential equation. So if you haven't watched all those previous videos, so go through all the previous videos and come back to this video, right? Okay. So far what we are doing in ODE is that we have been solving a first order differential equation, right? First order, first degree differential equation. So the very first class I have said that there are many methods to solve a differential equations of first order and first degree. So we have completed variable separable method, and then we have completed equation reducible to the form in which the variables are separated, and then we have completed homogeneous differential equations, and then equation reducible to homogeneous differential. Now we are in fifth subdivision, which is linear differential equations, right? So in the previous class, I have given you the introduction to linear differential equations, and then we have solved 15 problems based on linear differential equation, right? I just showed the notes of the previous class. So first we have defined what is meant by linear differential equation. That is whenever the equation of the form dy by dx plus py is equal to q, where p and q are functions of x, then that is called linear differential equations. And the solution is given by, so we have derived how to solve dy by dx plus py is equal to q, where p and q are functions of x and y. So we have derived a solution. We have got solution to be equal to y into integrating factor is equal to integration of q into integrating factor dx plus c, where integrating factor is given by e power integral of p dx, right? This is the formula, that is the solution for the linear differential equation. So you have to find the integrating factor using the formula e power integral p dx, and then you have to substitute back here to get the solution, right? So based on this, we have solved 15 problems based on this. So we'll continue with 16th problem, right? This is the continuation of previous class. So in the previous class, we have solved 15 problems, I think. Yes, so we have solved 15 problems the previous class. So we'll start with 16th problem, right? So in this class, we will complete a linear differential equation. After the next class, we will be moving on to next method of solving a first order, first degree differential equation, right? Okay, start. 16th problem, right? This is the continuation of previous class. Solve sin x dy by dx plus y cos x is equal to 2 sin square x cos x, right? So we'll start this. So first, we know that the coefficient of dy by dx must always be unity. So we will divide by sin x. So we will divide by sin x throughout. So this will become dy by dx plus cos x by sin x into y is equal to 2 sin square x cos x divided by sin x, right? So this will be dy by dx plus tan x into y is equal to, so this one sign will get cancelled. So we will have 2 sin x cos x, which is a linear differential equation, right? This is a linear differential equation, which is of the form dy by dx plus py is equal to q, where p and q are functions of x. Here p is tan x, q is 2 sin x cos x, right? Okay. The solution is given by what is solution? So y into integrating factor is equal to integration of q into integrating factor dx plus c. This is the solution, right? So we'll find integrating factor. What is integrating factor? E power integration of p dx So e power integration of, you can see p is tan x, right? So integration of tan x dx, right? This can be written as integration of tan x is sin x by cos x x. So derivative of cos x is minus sin x, but here minus is missing. So what we'll do is we'll multiply by minus 1 and minus 1, so that this will be f of x, f dash of x, right? F of x, f dash of x will be e power minus log of cos x, right? This can be written as e power log of cos x whole power minus 1, right? Because we know that we can take this to power. This is nothing but e power log x is x, right? E power log x is x. So this can be written as e power log of cos. Sorry. Yeah, cos by sin is cot, right? Sorry. Yeah, I thought it is sin by cos. We have this to be cos by sin is cot x, right? Cot x y is equal to sin x cos x. So e power integration of p dx is the integrating factor. This will be e power integration of, so what is p? P is cot x, right? Sorry, cot x dx will be e power integration of cos x by sin x dx. So you can see derivative of sin is cos x, right? So we know that integration of f dash of x by f of x is log f of x, e power log of sin x, which is nothing but sin x, right? So sin x is our integrating factor. So substitute in 1, right? Substitute in 1. So we know solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into sin x, right? Integration of, so what is q? This is q, right? This is q, this is p, right? P, this is q. So this is 2 sin x cos x. And what is integrating factor? It is again sin x dx plus c, right? So we have integration of 2 sin square x cos x, integration of, so we take 2 outside, we have sin square x cos x dx plus c, right? So we need to integrate this. So very simple, right? Just put t is equal to sin x. Therefore dt will be cos x dx. So this will be integration of, we have 2 integration of, so cos x dx is dt. This is t square dt plus c. So this will be 2 times t cube by 3 plus c. Now replace t is equal to sin x. Therefore 2 by 3, here we have y sin x. 2 by 3 sin cube x plus c is the required solution. Right? We have completed 16th problem. Now we'll move on to 17th problem. So solve 1 x square minus 1 x square minus 1 dy by dx plus 2 into x plus 2 into y is equal to 2 into x plus 1. Okay, so we'll solve this. So first what we'll do is we'll divide by x square minus 1. So that this will be dy by dx plus 2 into x plus 2 divided by x square minus 1 into y is equal to 2 into x plus 1 divided by x square minus 1, which is a linear differential equation, right? Because it is of the form dy by dx plus py is equal to q, where p is 2 into x plus 2 by x square minus 1. Q is 2 into x plus 1 by x square minus 1. Right? Solution is given by y into integrating factor, integration of q into integrating factor dx plus c. So now we'll find integrating factor. So e power integration of p dx. So e power integration of, so what is p? So p is 2 into x plus 2 divided by x square minus 1 dx, right? So let us take this 2 outside. X plus 2 by, so I can write x square minus 1 as x plus 1 into x minus 1, right? X plus 1 into x minus 1 dx. So let us call this to be equal to some star, right? Now we will find this integration value or substitute back here. So we can see this is a proper rational function, right? Degree of numerator is strictly less than degree of denominator. So we can do partial fraction directly. So consider x plus 2 divided by plus 1 into x minus. It has a into x plus 1 plus b by x minus 1. So multiply throughout by x plus 1 into x minus 1. Therefore, this will be x plus 2 is equal to a into x minus 1, b into x plus 1, right? I'm just doing partial fraction, which we have it already earlier, right? So put x is equal to 1. So this will be 3 is equal to, this will be 0. This will be 2b, right? So this implies b is 3 by 2. So put x is equal to minus 1. So minus 1 plus 2 will be plus 1. This will be minus 2a. This will be 0. Implies a is minus 1 by 2. Therefore, x plus 2 divided by x plus 1 x minus 1 is equal to, so a by x plus 2, sorry, x plus 2 divided by x plus 1 x minus. So this is a by x plus 1 plus b by x minus 1. So what is a? A is minus 1 by 2 into 1 by x plus 1. And b is 3 by 2, right? B is 3 by 2 into 1 by x minus, right? So I integrate on both sides. So if I integrate, so integration of x plus 2 divided by x plus 1 into x minus 1 dx is equal to minus 1 by 2 will be x plus 1 dx plus 3 by 2 1 by x minus 1 dx. This minus 1 by 2 log of x plus 1. This 3 by 2 log of x minus 1. This is the integration of x plus 2 by x plus 1 into x minus 1. So star becomes e power 2 times minus 1 by 2. This is the integrating factor, right? So from star we have, integrating factor is e power integration of p dx. So this will be e power 2 times. So integration of this value is minus 1 by 2 log x plus 1 plus 3 by 2 log x minus 1. So this 2 will get cancelled, right? And we know log a minus log b. So this can be written as e power log x, 3 times log x minus 1 minus log x plus 1. Can be written as e power log of x minus 1 whole cube minus log x plus 1, right? This is cube. So e power log a minus log b is log a by b. So e power log of x minus 1 the whole cube divided by x plus 1. E power log f of x is f of x. So x minus 1 whole cube divided by x plus 1. This is our integrating factor, right? So after finding integrating factor, solution will be The solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into integrating factor is x minus 1 the whole cube divided by x plus 1. Integration of q into integrating factor. So what is q? So q is 2 into x plus 1 divided by x square minus 1, that can be written as x plus 1 into x minus 1 into integrating factor, which is x minus 1 the whole cube divided by x plus 1 dx, right? Okay. So this x plus 1 will get cancelled. This x minus 1 will get cancelled. So we have y into x minus 1 the whole cube divided by x plus 1 is equal to integration of 2 into x minus 1 the whole square divided by x plus 1 divided by x plus 1 dx, right? So 2x minus 1 the whole square is x square minus 2x plus 1 divided by x plus 1 dx. Now remember, this is not a proper rational function. Degree of numerator is greater than degree of denominator, right? That means what? We have to do division algorithm now, right? So let us call this to be double star. Now to find this integration value, right? We need to find this integration and then the solution will be arrived, right? Now, what we will do is we will divide. We have to do division algorithm now. So we have to divide x square minus 2x plus 1 by x plus 1 into x, right? So x into x is x square, will be x square minus x. So this will be cancelled. This will be plus minus 2x plus x is minus x plus 1, right? So you can see both the degrees are same. That means x into what is minus x? X into minus 1, right? So x into minus 1 is minus x, plus 1 into minus 1 is minus 1. Again, change this. That means this x square minus 2x plus 1 can be written as x plus 1 into quotient plus remainder, right? Plus 1 into quotient plus remainder. So this can be written as, so the x square minus 2x 1 plus 1 can be written as x plus 1 into quotient plus remainder, right? Plus remainder. Already we have x plus 1 in the denominator, right? So very simple division algorithm, right? So a is equal to bq plus r, right? Okay. B into q plus r. Okay, x square minus 2x plus 1 into x is equal. Okay. Therefore, correct? Yeah. We have made some square. Yes, yes, I think we have made mistake. It will be plus x, right? This square plus x. Sorry. So this will be minus 3x. X into what is minus 3x? It has to be minus 3. It has to be minus 3. So x square plus x into minus. Okay, so very simple, right? So x into, we have to divide x square minus 2x plus 1 by x plus 1. So x into x is x square. 1 into x is x. So we will change the sign and then it will cancel this. So minus 3x plus 1. So x into what is minus 3x? It is minus 3. So x into minus 3 is minus 3x. 1 into minus 3 is minus 3. So we'll change the sign again. Will get cancelled. So we'll learn this to be equal to 4, right? That means x square minus 2x plus 1 can be written as x plus 1 into quotient plus remainder, right? This is quotient, this is remainder, right? Now we will separate and then we will integrate. So integration of, so when you divide this term by this term, you will have x plus 1 will get cancelled. So we will have x minus 3 dx. Divide this term, we will have 4 by x plus 1 dx, right? So I'm dividing x plus 1 separately, that's it. This will be 2 times. So integration of x minus 3 dx. So it will be x square minus 3. Integration of x dx is x square, x square by 2 minus integration of dx is x. It will be 4 times log 1 by x plus 1 is log x plus 1, right? This is the required solution. So x squared by 2 minus 3x plus 4 times log of x plus 1 plus c, the required solution. Right? So I'm just using division algorithm here. So x square minus 2x plus 1 can be written as this into this plus remainder, right? So we will solve 18th problem now. So solve 1 minus x square x into 1 minus x square dy by dx plus 2 x square minus 1 to y is equal to x cube, right? Okay, so we'll solve this problem. Any doubt up to now? Okay. So what we'll do is we'll divide by x square minus. We'll divide by x into 1 minus x square. So we have dy by dx plus 2x square minus 1 divided by x into 1 minus x square into y is equal to x cube divided by x into 1 minus x square, right? Which is a linear differential equation. The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Let's call this as equation number 1. Now we find integrating factor e power integration of p dx. So e power integration of p dx. So 2x squared minus 1 divided by x into 1 minus x squared dx, right? Okay. Now let us call this to be some star. Now we'll find this integration value and substitute back here, right? Now to find, now we will do partial fraction here to 2x squared minus 1 divided by x into 1 minus x squared, right? So this is a proper rational function. Degree of numerator is less than degree of denominator, right? This is 2, this is 3. Okay. This can be written as 1 plus x into 1 minus x, right? A square minus b square. So a by x plus b by 1 plus x plus c by 1 minus x. So multiply throughout by x into 1 plus x, 1 minus x. So we have 2x square minus 1 is equal to a into 1 plus x into 1 minus plus b into x into 1 minus x plus c into x into 1 plus x, right? Now put x is equal to 0. If you put x is equal to 0, we have minus 1 is equal to, and this will be 1 into 1. This is a, right? So a is minus 1. So put x is equal to 1. If we put x is equal to 1, we have 2 minus 1 is 1. Will be 0, this will be 0. We have this to be 1 plus 2. 1 into 2. This is 2c. Place c value is 1 by 2. And put x is equal to minus 1. So this will be again plus 1 is equal to, this will be 0, this will be 0. B will be minus 1, right? When you put x is equal to minus 1, this will be x is equal to 1. To 1 minus x, x into 1 plus x. When you put x equal to 1, we have 2 minus 1, right? 2 minus will be 1. X square minus 1. Okay. So when you put x equal to minus 1, we will have again 1. And this will be minus 1 into, will be half minus s. So we will have this to be 2b, right? So b is minus 1 by 2. So b is minus 1 by 2. So therefore, this 2x square minus 1 divided by x into 1 minus x square. So this will be a by x, b by 1 plus x plus c by 1 minus x. So what is a? A is minus 1, right? So minus 1 by x, b is minus 1 by 2 to 1 plus x, c is plus 1 by 2 into 1 minus x. So integrate this. So 2x square minus 1 divided by x into 1 minus x square dx will be integration of minus 1 by x dx minus 1 by 2 integration of 1 by 1 plus x dx plus 1 by 2 integration of x dx. So this will be minus log x, and this will be log of 1 plus x will be log of 1 minus x, right? It will be log of 1 minus x. What we can do is, okay, so if we take this minus outside, if we take this minus outside, okay, before that what we will do is minus, I'll take this minus outside here from these two terms, log x plus log of 1 plus x whole power 1 by 2, right? So I'm just taking this 1 by 2 to the power, I'm taking minus outside. So log a plus log b is log ab. This will be minus log x into root of 1 plus x, right? X into root of 1 plus x. Here we will have log of 1 minus x whole power 1 by 2, right? I'm just taking this power to the power. Log correct, right? So again, log a minus log b is log a by b, will be log of a by b. So root of 1 minus x divided by x into root of plus x, right? Log a minus log b. Correct, right? E is 1 by 2. The take this minus outside, we will have log A, log x plus 1 by 2 log 1 plus x. Log A plus 2 root of plus x. Okay, I think there is some like mistake I did. Third one dash of A value is correct, right? So 2x squared minus 1, take these values. We put x is equal to 1, will be 0, this will be 0. 1 plus 1 is 2, here you will have 1, and 2 minus 1 is 1 by 2, right? Correct, right? Any mistake? B and C are correct, right? So x is equal to 1, b 1, b is 1 by 2, b is minus 1 by 2, plus x by 1 by 2. Sorry. So here minus is missing, right? So what we'll do is we'll multiply and divide by minus. Minus 1 by 2 minus 1, right? So f of x, f dash of x. So derivative of this is minus 1. Will be minus 1 by 2, right? So again, this is correct, right? So minus log of, so log a plus log b, x into root of 1 plus x. Here you will have minus 1 by 2 log x. Okay, I think everything is audible, right? There is some internet problem. Okay, so again, if we take this minus outside, we will have log a plus log b, which is log ab. So x into root of 1 plus x to 1 minus x. So everything is audible, right? So minus log of x into root of 1 minus x 1 plus x. So if I multiply this inside, we will have minus log of x into root of minus x square, right? X into root of 1 minus x square. And if I take this minus, so therefore your star becomes, right? So star is your integrating factor. So therefore integrating factor will be e power integration of p dx. So integration of p dx is what that we have found now, which is e power integration of log of x into root of 1 minus x square whole power minus 1 dx. So this 2 will get don't have integration here. So integration of p dx value is this, right? So therefore this will be e power log will get e power log f of x is f of x. So we will have 1 divided by x into root of 1 minus x square is our integrating factor, right? Now the solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into 1 divided by x into root of 1 minus x square is equal to integration of, so q is x cube divided by x into 1 minus x square into what is integrating factor divided by x into root of 1 minus x square dx plus c. This will be integration of 1x will get cancelled. Again, this x will get cancelled, right? So we will have this to be we will have 1x here, right? So we will have 1x and 1 minus x square into 1 minus x square whole power 1 by 2 will be 1 minus x square whole power 3 by 2. So bring this term to the numerator into dx plus c, right? Into dx plus c. So we have, so you can see this x into x is x square. 1x, this x square will get cancelled. So we have x into 1 minus x square whole power minus 3 by 2. So put t is equal to 1 minus x square. So dt will be minus 2x dx, right? Minus 2x dx. So what we'll do is we'll multiply and divide by 2. Multiply and divide by 2 will be 1 by 2 integration of, so 2x dx is dt. Okay, minus 2x is dt. Okay, so this will be minus dt. So this will be 1 minus x square is t. So t into t power minus 3 by 2 into minus dt plus c, right? Minus 1 by 2. This will be integration of t power minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1 plus c. So this will be minus 1 by 2 will be what? Minus 3 plus 2 minus 1 by 2. So if I take this to numerator, we'll have minus 2 and this will be t power minus 1 by 2 plus c, right? 2 minus. So these 2 will get cancelled. So we will have minus minus will become plus. So 1 divided by, so what is t? T is 1 minus x. Just writing this to be 1 by t power 1 by 2, replace t. Is the required solution. And this will remain as it is. Y into x into root of y into 1 by x into root of 1 minus x square is equal to 1 divided by root of 1 minus x square plus c is the required solution, right? So we have solved 18 problems up to now. So we'll continue with the 19th problem. I'll give you some exercise problems for you also, because I don't want to solve all the problems for the book. I'll give you some exercise problems also. I'll do one more problem. After that, I'll do some exercise problem. So 19th problem. So solve x into x square plus 1 dy by dx is equal to y into 1 minus x square x cube log x. We'll solve this. So what we'll do is we will divide by x into x square plus 1. So this will be dy by dx. dy by dx is equal to y into 1 minus x square divided by x into x square plus 1 x cube log x divided by x into x square plus 1. So we have dy by dx plus minus of 1 minus x square divided by x into x square plus 1 into y is equal to x cube log x divided by x into x square plus 1, which is a linear differential equation, right? So dy by dx plus py is equal to q, where p and q are functions of x. Okay. So the solution is given by y into integrating factor integration of q into integrating factor dx plus c, right? Now we will find the integrating factor e power integration of p dx. So e power integration of p dx. So p is minus of 1 minus x square divided by x into x square plus 1 dt. X into x square plus 1 dx. Okay. Now we have to integrate this. Actually, you can do partial fraction also using type 3 partial fraction, a by x plus bx plus c divided by x square plus 1, but it will take time. What we will do is we will use some substitution here. Already we have solved this kind of problem, right? Already we have solved this kind of problem. What we'll do is put x square to be equal to t. Therefore, 2x dx will be dt, right? So what we'll do is we'll multiply and divide by 1 by 2, 1 by 2. Right? This we multiply and divide by 2. So this will be e power minus 1 by 2 integration of 1. Wait a minute. Okay, yes, 1 minus x square. That means 1 minus t. 1 minus t divided by x into x square plus 1, right? X into x square plus 1. So therefore, this will be the question is x square. The question is x square into x square plus 1. Okay, okay. So what we can do is correct. What we can do is we should have 2x dx, right? Okay. So what we'll do is we'll multiply and divide by x also, right? Multiply and divide by x also. Don't want to confuse. Let's make it simple. So we have this as minus 1 minus x squared, right? Okay. So what we'll do is we can convert this to x squared minus 1 and then we'll plus. Now what we will do is first we need to have 2x dx, right, as dt. So we will multiply and divide by 1 by 2x, 2x, right? We multiply and divide by 2x. So 1 by 2x into 2x, right? So 1 by 2x into 2x. So 2x plus will get cancelled. Now you can see this can be written as e power 1 by 2 integration of, right? Integration of x square minus 1 divided by, multiply this x with this. So we will have x square into x square plus 1 2x dx, right? Now make use of substitution. So e power 1 by 2 integration of t minus 1 divided by t into t plus 1 dt, right? This is dt 2x dx. Now we will do partial fraction here for t minus 1 by t into t plus 1. Let's call this to be equal to star. Let's do partial fraction for t minus 1 divided by t into t plus 1. So we will have a by t plus b by t plus 1. So put t is equal to 0. We put t is equal to 0 or we will multiply throughout by this. So this implies multiply by t into t plus 1 implies t minus 1 is equal to a into t plus 1 plus b into t. Right? So put t is equal to 0. If you put t is equal to 0, we will have minus 1 is equal to a, right? If you put t is equal to minus 1, so minus 1 is minus 2, it will be minus b, implies b value is 2, right? So a is minus 1 and b value is plus 2. So t minus 1 divided by t into t plus 1. A value is minus 1, b value is 2. Right? Now we integrate, so integration of t minus 1 by t into t plus 1 dt. Integration of minus 1 by t dt. Integration of 1 by t plus 1 dt. This minus log t. This 2 times log t plus 1, right? Log t plus 1. So this can be written as t plus 1 whole square, right? T plus 1 whole square. So 2 by t plus 1 e power log t. So therefore this star becomes e power 1 by 2. This is integrating factor, right? So e power 1 by 2, this integration value is minus log t plus 2 times log t plus 1, right? This is the integrating factor. So if you multiply this 1 by 2 inside, we will have this to be equal to this 2 into 2 will be plus 1. So e power log of t plus 1 minus 1 by 2 log t, right? So log a minus log b will be log a by b. So e power log of t plus 1 by root t, right? Because I can take this 1 by 2 to the power. So we will have t power 1 by 2. So log a minus log b will be t plus 1 by root t. E power log f of h is f of x. So replace t is equal to what? X square. x square plus 1 divided by root t. X square plus 1 divided by x is an integrating factor, right? X square plus 1 divided by x is your integrating factor. Now we need to find solution. The solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into integrating factor is x square plus 1 divided by x integration of q. So q is x cube log x divided by x into x square plus 1 into integrating factor, which is x square plus 1 divided by x plus c square plus 1. This x is x square. We will have integration of we will have 1x in the numerator, so which is integration of x into log x dx plus c. So you have to apply uv, right? udv. So uv minus integration of v du. So you have to choose u in the order I laid. So here we have algebraic as well as logarithmic, but you have to choose logarithmic first. So put u is equal to log x and dv is equal to x dx, right? dv is x dx. So therefore your du will be 1 by x dx, right? Differentiate with respect to x, du by dx will be 1 by x and v is x square by 2. This will be log x is x square by 2. Integration of v is x square by 2 du. So du is 1 by x dx. So this will be x square by 2 log x minus x by 2 dx, right? X by 2 dx. So this will be x square by 2 log x minus 1 by 2 integration of dx is x square by 2. This is the required solution, right? So y into x square plus 1 divided by x equal to x square by 2 log x minus 1 by 4 x square plus c is the required solution. So we'll solve 20th problem and then we'll move on to another type of this problem. So 20 is solve dy by dx plus y divided by 1 minus x square whole power 3 by 2 is equal to x plus root of 1 minus x square divided by 1 minus x square whole square, right? So I can see this is a linear differential equation dy by dx plus py is equal to q, where p is 1 minus x square whole power 3 by 2, q is x into root of 1 minus x plus root of 1 minus x square divided by 1 minus x square whole square. So we'll do this. This here linear differential equation. The p value here is 1 divided by 1 minus x square whole power 3 by 2. The q value is x plus root of 1 minus x square divided by minus x square whole square, right? Solution is y into integrating factor integration of q into integrating factor dx plus c, right? What is integrating factor? E power integral of p dx, right? Now we will find integration of p dx and then we will raise e, right? Now integration of p dx. So integration of 1 divided by 1 minus x square whole power 3 by 2 dx, right? So what I'm going to do is I'm going to put x is equal to sine theta, right? So when we already did one problem in variable separable method where we have x square and y square in the term. So what we did there was put x is equal to r sine r cos theta, y is equal to r sine theta. We have converted that to polar form, right? Here also I'm going to make use of that. Put x is equal to sine theta, right? Just going to put x is equal to sine theta. Therefore, your dx will be cos theta d theta, right? Cos theta d theta. Now, what I'm going to do is, what we can do is, before that, we will substitute back here. So, integration of 1 divided by 1 minus sine square theta whole power 3 by 2. Dx is what? Cos theta d theta, right? Cos theta d theta. This will be integration of 1 minus sine square theta is cos square theta. So, this cos will get cancelled. So, we will have this to be 1 by cos square theta whole power 3 by 2 to cos theta d theta. This will be integration of cos theta divided by cos cube theta d theta, right? This is nothing but 1 divided by cos square theta, which is integration of secant square theta, right? This is nothing but integration of secant square theta, which is nothing but tan theta, right? So integration of secant square theta is tan theta. This R is written as integration of d by d theta of tan theta d theta, right? So tan theta. So therefore integration of p dx is tan theta, but we need to have in terms of x. But here we have in terms of theta. So we should have in terms of x, right? So what is x? X is sine theta, right? So therefore we will have theta to be sine inverse of x. Theta to be sine inverse of x. So therefore this will be tan of sine inverse of x. Or what we can do is, we have tan theta, right? X is sine theta, right? Okay. What we have is x is sine theta is equal to x. Okay. So what we can have, we can write tan theta to be equal to sine theta divided by cosine. What we can do, right? What we can do is, so we have x to be equal to sine theta and we have this to be tan theta. Okay. So we have tan theta, I can write that to be sine by cos. Okay, do like we will write like this. So tan sine theta by cos theta. So this is sine theta divided by, so we know sine square theta plus cos square theta is 1. So cos square theta is 1 minus sine square theta. So therefore cos theta will be root of 1 minus sine square theta, right? Cos theta, root of 1 minus sine square theta. And you know sine theta is x. So x divided by root of 1 minus x square is your integration of p dx value. X divided by root of 1 minus x square is your p dx value, because we need to convert in terms of x, right? So therefore integrating factor is e power integration of p dx. E power integration of p dx is x divided by root of 1 minus x square, right? Yes. What is solution? Solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into integrating factor is e power x divided by root of 1 minus x square is equal to integration of, so what is q? Q is x plus root of 1 minus x square divided by 1 minus x square whole square into integrating factor, which is e power x divided by root of 1 minus x square dx plus c, right? Now we need to integrate this entire term now. So for that, I'm going to make use of the substitution. Put x is equal to sine theta, right? X is equal to sine theta. Therefore, your dx will be cos theta d theta, right? Dx will be cos theta d theta. Will be integration of, so x is sine theta 1 minus sine square theta minus sine square theta whole square e power x by root of 1 minus x sine theta divided by root of 1 minus sine square theta. And what is dx? Dx is cos theta d theta plus c. This will be integration of sine theta 1 minus sine square theta is cos square theta. So this root will get cancelled. We will have only cos theta. 1 minus sine square theta is cos square theta. So cos square theta whole square will be cos power 4 theta. Here we will have e power sine theta by cos theta, right? We will have cos square theta, root will get cancelled, into cos theta d theta plus c. Okay. So again, this one cos will get cancelled, right? Cos will get cancelled. This will be integration of sin theta plus cos theta. Just write like this, right? Into cos theta. Here you will have cos cube theta, right? So 1 by cos square theta into e power tan theta d theta plus c. Sin theta by cos theta is tan theta. Okay. So what I'm going to do is 1 by cos square theta is secant square theta. So integration of if I separate by cos theta, right? So sin theta by cos theta is tan theta. Cos theta by cos theta is 1. 1 by cos square theta is secant square theta into e power tan theta d theta plus c, right? Very simple. Put z is equal to tan theta. That's it, right? Put z is equal to tan theta. Therefore, your dz will be secant square theta d theta, right? So secant square theta d theta will be dz. This will be integration of z plus 1 into e power z dz plus c. That's it, right? So just make it, just refer here, right? So z plus 1 dz, this is e power z plus c. Now we can make use of um, integration by parts. We'll have this to be equal to integration of z plus 1 e power z dz plus c. Put this ub minus integration of b du. So we have u to be equal to z plus 1, dv to be equal to e power z dz. So we have du to be equal to dz, v to be equal to e power z again. So u into v. So z plus 1 into e power z, integration of e power z dz. So again this is e power z. So if I take e power z common, you will have z plus 1 minus 1, right? So this will be z e power z. That's it, right? So replace z to be equal to tan theta, as that is tan theta, right? So tan theta e power tan theta. We know tan theta is sin theta by cos theta. And we know cos theta is root of 1 minus square theta. So by our substitution, x is sin theta. So x divided by root of 1 minus x square into e power x divided by root of 1 square is the required solution. Right? Here we have the same term y into e power x divided by root of minus x square. Right? This is the required solution plus c. So very simple problem. Now we'll move on to actually the same method. So instead of we know equations of the form. So now we are going to move on to case 2 in solving linear differential equation. Usually the pattern for linear differential equation is dy by dx plus py is equal to q, where p and q are functions of x, right? Now we are going to move on to case 2. Equations of the form dx by dy plus px is equal to q. So instead of y, we have px is equal to q, where p and q are functions of y, only, right? So instead of dy by dx, we have dx by dy plus px equal to q, where p and q are functions of y. This is case 2 of linear differential equation. The solution is given by, I'm going to add like the solution, right? Solution is, there the solution is y into integrating factor. Here the solution is, we have to replace everything x by y, that's it. Solution is x into integrating factor, integration of q into integrating factor into dy plus c. This is a solution, right? Usually there we will have y into integrating factor, q into integrating factor, dx plus c. Here you will have x here, dy here, where what is integrating factor? E power integration of p dy. There you will have p dx, here you will have p dy. That is, you have to change the variable of everything x to y. That's it, right? It's the solution, right? The same method, right? Whatever we did there, you have to do the same method. I'm just going to do only one problem based on this, right? Very simple. Same method, instead of integrating with respect to x, need to integrate with respect to dy, right? No problem. Here p and q are functions of y only, right? So this p is a function of y, so integrate with respect to y, and also this q is also a function of y. Integrating factor is also a function of y. So integrate this entire function with respect to y, you will get the solution. Okay, so we'll move on to problem 21. Solve x plus 2y cube dy by dx is equal to y. We'll multiply this here. So we will have x into dy by dx plus 2y cube dy by dx is equal to y, right? Okay, so what we'll do is we'll convert this to in this form. So you can do in any method, right? You can also convert this to case 1 also. So we will do like y into dx by dy, right? Y into dx by dy x plus 2y cube. So we have y into dx by dy plus x is equal to 2y cube. So we'll divide by x and we'll divide by y. So we will have dx by dy plus minus 1 by y into x is equal to 2y cube by y. You can see it is a case 2 differential equation, linear differential equation, right? Dx by dy plus px is equal to q, where p and q are, which is linear differential equation case 2. So what is p here? P is minus 1 by y, q is 2y square, right? Q is 2y square. What's the solution? Solution is y into integrating factor is equal to integration of, into integrating factor, right? X into integrating factor is equal to q into integrating factor dy plus c. This is the solution. Now we will find integrating factor e power integration of p dy. Integration of p dy is minus 5y dy. So this will be e power minus log y. So e power log y power minus 1. This is y power minus 1. So 1 by y is your integrating factor. So from 1 we have x into integrating factor is equal to integration of 2 into integrating factor dy plus c. So x by y is equal to y dy is y square by 2 plus c, right? This is the required solution. Everything is same, right? The only thing is instead of dy by dx plus py is equal to q, we are going to have dx by dy plus px is equal to q, where p and q are functions of x, right? Everything is same. I will do only one problem now, and then we'll find out. Use some exercise problem in Telegram group based on this. So solve sin x dy by dx is 3y equal to cos x, right? Actually, this comes under case 1 only, right? You can solve in case 1 or case 2. It's up to your wish. So I'll solve it using case 1. If we solve using case 1, we divide by sin x. So this will be dy by dx plus 3 by sin x into y and cos x by sin x, which is here linear differential equation. The solution is given by y into integrating factor case 1 only. You can also find dx by dy by cross multiplying it. No. Integration of q into integrating factor dx plus c. Let's call this to be equal to 1. Let us call equation number 1. Now we'll find integrating factor e power integration of p dx, e power integration of, so p dx. So p is 3 by sin x dx, right? 3 by sin x dx. So this will be e power d into integration of 1 by x dx. I given you this formula, right? I already given this formula. So integration of cosecant x is tan x by 2, right? Integration of cosecant x is tan x by 2. log tan x. This take this 3 to the power. We will have so tan cube x by 2, right? So tan cube x by 2 is the integrating factor. Solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. Integrating factor is tan cube x by 2. Integration of, so what is q? Q is cot x by sin x, is cot x. This cot x tan cube x by 2 dx plus c. This cot x is 1 by tan x. So tan cube x by 2 by tan x, right? So I'm going to make use of the formula. Tan x can be written as 2 tan x by 2 divided by 1 minus tan square x by 2, right? This is half angle formula which we will use in trigonometry in 11th 12th itself. Tan x can be written as 2 tan x by 2 divided by 1 minus tan x square by 2. So this will be tan cube x by 2. So instead of this tan x, I'm going to write this, right? 2 tan x by 2 divided by 1 minus tan square x by 2 dx plus c will be integration of, if I take this to power, 1 minus tan x square by 2. So 1 minus tan x square by 2. And this will be 1 tan will get cancelled, right? We will take this 1 by 2 outside. 1 tan will get cancelled. We will have tan square x by 2 dx plus c, right? That's it, right? From now on, it is very simple. Put tan x, put put t is put t is equal to tan x by 2. Therefore, what about dt? Dt will be secant square x by 2 into 1 by 2 dt, right? If we differentiate this secant square x by 2, we differentiate inside, we will have 1 by 2 dt. So dt dx. Therefore, we will have this to be by 2 integration of 1 minus t, right? This is 1 minus t. Uh, secant square theta minus tan square theta is 1, right? Okay, so do this. It will be t square with t square. Okay, plus 2 will be 1 minus t square. This minus t square into t square, right? Because t is tan x by 2. And what about dx? Dx is, let's take this 2 to that side, right? So 2 dt, dx is 2 dt divided by secant square x by 2, right? This will be 1 by 2 integration of t square 1 minus t square 2 dt divided by, so this can be done as secant square can be done as tan square x by 2 plus 1, right? Just using the identity, right? Tan square x by 2 plus 1. Secant square theta minus tan square theta is 1, right? Therefore, secant square theta can be done as 1 plus tan square theta. That's what I'm writing here. So this will be by 2 t square into 1 minus t square 2 divided by this again 1 plus t square, right? This again 1 plus t square dt. 2 will get cancelled. So we will have integration of, to multiply this inside, we will have minus t power 4 plus t square divided by t square plus 1 dt, right? Now you can see it is not a proper rational function because degree of numerator is strictly greater than degree of denominator. So we will make use of division algorithm. So we have to divide minus t power 4 plus t square by t square plus 1, right? So t square into minus t square is minus t power 4. This is minus t square. If I change sign, we will have plus, we will have plus. We will have 2t square. T square, this will be into 2. We will have 2t square plus 2. So if I change sign, this will be minus 2. This can be written as, so t minus t power 4 plus t square can be written as t square plus 1 into quotient plus remainder, right? Whole divided by t square plus quotient, this remainder. This can be written as this into this plus remainder. So when I divide separately, we will have integration of these two will get cancelled. So minus t square plus 2 dt, and here we will have minus 2 times 1 divided by t square plus 1 dt. So minus t square dt is minus t cube by 3. This will be integration of dt is t, and this is tan inverse of t, right? Tan inverse of t plus c, right? That's it. So replace t is equal to tan x by 2, right? What is t? T is tan x by 2. Two times tan inverse of is the required solution. You can also cancel this tan inverse of tan x. You can also cancel these two term, and also can cancel this 2 too. No problem, right? Yeah, in the LHS part we have y into tan cube x by 2. Right? This is a required solution. So that's it. So we'll stop here. So we have completed the topic linear differential equation, right? So we have solved 22 problems based on linear differential equation. I'll just show you the slide of the very first class. The very first class I have given you that there are many methods to solve a differential equations of first order and first degree. So we have completed the first 5, right? First 5. Next, what we're going to do is we're going to move on to the next method, right? We're going to move on to next method, which is called Bernoulli's equation, right? Actually, we will solve Bernoulli's equation before moving to the next method, right? So it is somewhat similar to this pattern, right? So in the next class, we will solve Bernoulli's equation. After that, we will continue solving more problems, right? Any doubt? Okay, so next class, we're going to start Bernoulli's equation, right? How to solve Bernoulli's equation. But we will move on to next class, right? Okay, thank you. We'll